Okay, let us discuss problem number 1.74. So let me first make the diagram. If you've tried this one at home, this is a quite interesting problem. This side you have a rope and there is a mass M, and this rod has a mass of M and length L, and there is a friction force between this mass and this rope. So let us say friction force between rope and mass is F. This rod has a length L. Initially this mass M is basically the lower end of this rod. Now this mass object has a hole so that it can slide. So this ball can slide inside this rope. Basically, if you see, this will look something like this. So this is a object and there is a hole. So through this hole, this rope can slide, but this cannot slide freely. There is some friction between rope and this hole, and that's why there is a friction that is exerting between rope and so what will happen if this is completely smooth? This mass will go down, but there is a friction, so this friction will basically act up on this mass, so there is a less tendency to go down. So on this hole there is acting a friction force. Of course mg will also act. So if the friction force on the object or on the ball is acting up, so friction force on this rope will act downward. So friction force on the rope will act downward. We're getting same Newton's third law. The magnitude will be biased, both will be same. So in this whole system, friction force is F. So here also there will be a force that is acting upward direction. Let us call this the F. So tension in this string will be F. Now what we have to find out, it is given after time t this mass reaches to the other end, this end. So after time t, situation is something like this. This mass is initially here, that is the lower end. After time t, this reaches here. So we have to find out the friction force value of F. So it is given. So at t is equals to t, the ball reaches up to other end. Ball reaches to other end. So how will you proceed? Let us see the free body diagram. Let us say this object M is going downward. So this has a acting forces are mg. F is acting up. Let us say this mass is coming down with acceleration a1. You're getting. Now let us say for this mass, the bigger rod, the friction force that is acting up, this will also have mass mg that is acting downward. You're getting or not? Now this is, let us say, this is also coming down with acceleration a2. So how this is possible? So you see, this is going down, this rope will go up, but this mass is going down. This is obvious because you see, if there is no friction, this object with a hole will slide down. If there is a friction between these two, it will slide again down, but with a smaller velocity, with a smaller acceleration. This will not go down with acceleration a or acceleration g. This will go with a smaller acceleration, that is acceleration of this should be lesser than z. Now this will go again down because mass is big, so this friction force is not as great as mg. So mg will be basically bigger force, so this will go down. One thing is also given to you, m is greater than m. So from here you can say that this side force, that is the maximum friction force, that will always less than a small mg. So this side mg, so Fv is less than mg, and this is the capital Mg should be always greater than a small mg, so this will go down and this will also go down. Now see, if you sit on this bead or if you sit on this ball, you will see what we will see. You will see this rod has traveled a distance of L. Initially you will look, this rod is here. After some time this end will here. So if you sit on this bead, you will see rod has traveled a distance of L. So this means I am interested to find out the distance traveled by this rod with respect to this ball. So let us say I am interested in, so distance by rod with respect to bead. So with respect to ball you can say this is L. Are you getting on? This is given to you. So now I will be interested to acceleration of rod with respect to ball. So what will be this acceleration? Because both are going down, so I have to subtract acceleration of ball from acceleration of this mass rod, that is the acceleration of A2 minus A1. So this is the acceleration of rod with respect to ball. Now if you see, initially both are in the rest. So initially this as well as this both are in the rest. So initial velocity U relative is 0. Now I can apply S is equals to ut plus half at square. So S relative is equals to U relative plus half at square. Now I know, so A is also relative. So S relative is distance traveled by this object. The bigger rod is L. Initial relative velocity is 0. And relative acceleration is A2 minus A1. And time is t square. This is given. So t is given to you. So this question says after time t, this a smaller object in the at the upper end of the rod. So t is given. So t is given. So let us say t is given in the problem. So let us copy this one and then we'll discuss next. So if you have missed something from top, let us copy fast. Now we have to simply write down the equation for A2 minus A1. So what we can do is, I will copy this one. Now I can write equation of motion. For mg, I can write equation of motion is mg minus f. So f is acting upward. So I think you are not able to see this one. This is f. This is again f. This is acting upward. This A2 is acting downward. Now this is mg. This is going downward with acceleration A2. Now I think you are able to see this one. So let us say write down the equation of motion for this. So mg minus f is equals to ma2. So let us say mg minus f is equals to ma2. So from here I can write a2 is equals to z minus f by m. So this is my equation 1. Now similarly I can write equation number 2 for this mass, a smaller mass. So this is again going downward. So mg minus f is equals to ma1. So let us say, so I think you have copied this one. So let us remove this one. mg minus f is equals to ma1. So I can write z minus f by m. This is equals to a1. Now I need a2 minus a1. So what is a2 minus a1? a2 minus a1 is z minus f by m minus z by f by m. So you will have z goes out, so you will have plus. So f by m minus f by m. You see this term is a positive because, so you will have m minus m into f. So if m is larger mass, so this is positive. So a2 minus a1 is basically positive. this m is greater than m, so this is basically positive. Now I can apply the same thing in s is equals to ut plus half at square relation we have written. So you see your copy, we have written L is equals to 0 plus half a2 minus a1 into t square. Are you getting or not? So this equation we have written earlier, so you can see your notebook, or I can show you. So something like this. So you see this equation we have written. So this equation, S relative is equals to U relative plus half A relative into T square, this equation. Now I know the A2 minus A1, so I got this A2 minus A1 from writing the equation of motion. So for object 1 I have written equation, I have written equation 2 for object 2, and then I have subtracted A2 minus A1. And important point is this A2 minus A1 is basically independent from G. G goes out. There is no G in this case. So I will have L is equals to, let us plug the value of A2 minus A1. I think you are able to see this one. Half A is m minus m, m into m t square. Are you getting? So from here you will have T is equals to 2L mm. Friction force is also there. So this is F half A T square. So there will be F. So T T square is 2L mm divided by basically I need F square. F. Okay, let us plug this value. So T square is 2L mm divided by m minus m into F. So this is we are getting. Basically we have to find F. So F will be 2L m into m divided by m minus m into T square. This is nothing but equation solving. You can do your own. Have you copied this one or not? So in this question, what is important point is, relative acceleration. So equation S is equals to ut plus half at square can also be written in terms of relative. You see, the bead, the small ball, has traveled a distance L. The rod has traveled a distance L with respect to the bead, with respect to the ball. So to find out the distance traveled by this rod, I have to subtract the acceleration of ball, and then I can write equation of motion. So important point in this case is we have to see this is the relative distance is L with respect to ball, with respect to the bead. If somebody is sitting on the bead, he will see the rod has traveled a distance L. That is the important point. And then I have to write S is equals to ut plus half a t square in relative form. So S relative is equals to U relative plus half acceleration relative into t square. So A relative is A2 minus A1. Initial velocity, both have initial velocity 0. So this means U relative is 0 minus 0, that is 0. And S relative is L, so I can apply S is equals to ut plus half a t square. From there I can get the friction force, the value of friction force. I think if you have copied this one, then we can go for the next problem.